In the previous lectures, we have seen the momentum of inertia of different shapes like a spherical shell and solid cylinder about the different axes of the rotation. And in this lecture, we are going to see the motion of this spherical shell and the solid cylinder rolling down on an inclined plane. Suppose this is an inclined plane, and here is that spherical body or the solid cylinder. Now let me call this as the position P at the time t is equal to 0. So this sphere or the solid cylinder is at a rest, and after time t it will reach this point. So let me call this point as a Q. So this solid cylinder or the sphere is kept at a height of h, and let theta be the angle, and let me call this distance as s. So this is nothing but the linear acceleration of this solid cylinder or the sphere. Now when this sphere or the cylinder is at a rest at point P, then its potential energy is given by mg into h, where m is the mass of the body, g is the acceleration due to gravity, and h is the height from the earth's surface. Now when this body rolls down this inclined plane, then it will follow the translation motion, and along with that it will go a rotational motion. Okay, so the motion on an inclined plane is translation motion plus rotational. So this solid cylinder or sphere, it is moving in a forward direction, which we call it as a translation motion, and while moving from this position to this position, so it is rolling also, so that is called as a rotational motion. So motion of a body along the inclined plane consists of translation as well as rotational motion. So we know that this translation motion is nothing but it is given by 1/2 mv square, where v is the linear velocity and this rotational motion is given by 1/2 I omega square, where this omega is the angular velocity. And we know that this I is moment of inertia of that rotating body. In the last unit, we have seen the laws of conservation of the energy, which says that energy can neither be created nor it can be destroyed. So this potential energy is converted into the kinetic energy. So this potential energy is nothing but equal to the kinetic energy, and this is nothing but the kinetic energy of a body rolling down an inclined plane. So this mgh is equal to 1/2 mv square plus 1/2 I omega square. So we know that v is equal to r omega, and therefore this and we also know that this I is equal to m into k square. So we can put these two values in this equation, and therefore we are going to get m 1/2 m r square omega square plus 1/2 m k square omega square. So this is mass is same. So if we take the common 1/2 m omega square, so it will be r square plus k square, and this is nothing but m into g into h. So this m will get cancelled, and I can write 2gh is equal to omega square r square plus k square. I can put this omega as v upon r from this equation. So just let us put value of this omega as v square upon r square plus k square. So I can write r square plus k square upon r square 2gh, or I can write v square is equal to 2gh upon r square plus k square upon r square, or I can write this v is equal to or 2gh r square plus k square upon r square raised to 1 half. Hold this one. By using the kinematic equations, we can write the v square is equal to u square plus 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, and s is the displacement. Now considering this u is equal to 0, we can write v square is equal to 2as, and we have also calculated the value of the v previously, or v square, as 2gh upon r square plus k square upon r square. Now comparing this equation and this equation, we can write 2as is equal to 2gh upon r square plus k square upon r square. Now by using the trigonometry in this triangle, we can write this sine theta is equal to h upon s, or I can write this h is equal to s sine theta. Now if I put the value of this h as s sine theta, so this s will get cancelled, this 2 will get cancelled, and we can write this a as r square g upon r square plus k square. This is the acceleration of a rolling body down an inclined plane. Now let us calculate this acceleration for a spherical shell. So for a spherical shell which is rolling down about an axis, now the axis of the rotation for the spherical shell will be like this, and the momentum of inertia of this rolling body passing through one of the end. Okay, so that is given by I is equal to 1 half mr square, and for this case, so this k square is equal to 2 by 3 r square. So this is the radius of the gyration. So this is a relation between the radius of the gyration and the radius. Now putting these two values in this equation, we can get, so the value of r square upon r square plus k square will be, so k square is 2 by 3 r square. Just let us put the value of this k square. So r square plus 2 by 3 r square. Now this r and this r are same, so the equation will be 5, so this will be 5 r square upon 3, so this will be 3 by 5. R square will get cancelled. Call this as a, let us call this as equation number 3. Now let us put this value of r square upon r square plus k square as a 3 by 5. Therefore we are going to get this a is equal to 3 by 5 into g. So I have forgotten sine theta over here. G sine theta upon r square plus k square. So we have to add here g sine theta. So this is the acceleration of a spherical shell rolling down an inclined plane. Now let us calculate the same acceleration for the solid cylinder. For a solid cylinder, we have already calculated the momentum of inertia, so that I was 1 half m into r square, but the relation between the radius of the gyration and the radius is k square is equal to 1 half r square. So the value of this r square upon r square plus k square will be r square plus this 1 half r square. This r and this are same, so it will be 3r square upon 2, so it will be 2r square upon 3r square is equal to 2 by 3. And now if I put this value of this r square upon r square plus k square as 2 by 3 in this equation, so this a will become 2 by 3 into g sine theta. Now this is nothing but the acceleration of the solid cylinder rolling down an inclined plane. Now from this expressions we just come to know that whenever there is any body rolling down an inclined plane, so the body consists of the translation motion as well as the rotational motion. So it will have the linear velocity as well as the angular velocity. It will have linear acceleration as well as the angular acceleration.